Hello everyone, I'm Snigdha Kakkar and this is my channel Accelerate AI Careers. Today, I'm going to bring 7 questions asked in FAANG interviews in last 1 month. So this is quite critical series of my videos which I'll be launching this week, where you'll have almost 35 questions in your bucket which have been asked in last 1 month of interviews. So if you are aiming at cracking any of the 5 interviews, do stay tuned and just help me out. Mention anything in the comments here, whatever you like, whatever you don't like, or just an emoji. It helps with the algorithm of the YouTube here. So let's dive into our first question here. Our first question is 1004 lead code problem, max consecutive ones, 3. What does this question say? So you have been given a binary array nums and an integer k. You have to return the maximum number of consecutive ones which are possible in the array if you can flip at most k zeros. So basically, you might have zeros in between ones in the array, and you can flip at most k zeros. Okay. So let's look at the examples given here in the question to understand the question better. For example, 1 nums is 111 000 11110, and k given to you is 2. What does this mean is that you can flip at most 2 zeros. So let's look at what zeros we can flip. So we start from 0th index and we see that the first zero which occurs is here at index 3. Maybe we can flip that and we can flip the next zero. If we do that, we have maximum of 5 consecutive ones possible. So let's save that somewhere. Now let's look ahead if we could flip this zero and this zero. In that case, we will have 1, 2, 3, 4, 5, 6. We will have 6 ones consecutively. So that's max consecutive ones which are possible. Can we do better? So we can flip this 0 last and last this 0. Then again, we get max consecutive ones as 6. So our number doesn't change. So our maximum consecutive ones possible if we are allowed to flip 2 zeros is 6. That's around. Now let's look at another example here. So here you have been given in example 2 that you can flip at max 3 zeros. And if you can flip 3 zeros, let's start from 0th index and check. Suppose I flip the first 3 zeros here. 1, 2, 3, 4, 5. Then my max consecutive ones would be 5. Can I do better? Let's move ahead. Maybe I can flip this 0, and this 0. In that case, I'll have 1, 2, 3, 4, 5, 6, 7, 8. 8 ones together. So it's better than the prior output. Let me save it somewhere. But can I even do better? Maybe I need not flip the first 2 zeros and I can flip the next 3 zeros. So I flip this one, and this one. In that case, my output would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, it is more than the prior max consecutive one. So I will save this as an output. Now, is there any better outcome I can achieve? You can check all the permutations and combinations. You will find that this is the best output which you can get by flipping 3 zeros. So that's how my output is 10 here. Now let's look at how we code it. So according to me, this is an easy level question and not a medium level question because the logic behind it is very easy and it's maximum of 8 to 10 lines of code. You will see when we start coding it. But the algorithm behind coding it would be 2 pointers approach. We'll be using a left pointer and a right pointer and a sliding window. So the right pointer will keep on moving and checking for the presence of zeros, and we will keep on decrementing k as and when we'll flip zeros. And as soon as our k becomes less than 0, we will start moving our left pointer so that k is never less than 0. As soon as k becomes less than 0, we have to return the extra zeros we are flipping, right? That we do by moving the left pointer. So basic approach, 2 pointer approach, move the right pointer fast, check for the presence of zeros and keep on decrementing your k as and when you are moving your right pointer, and keep on updating your max consecutive ones as well. So max consecutive ones, what would it be? It would be a max of current max consecutive ones and right pointer minus left pointer plus 1. So basically every time until your k is positive, you can increment your r, you can check for max consecutive. As soon as k becomes less than 0, you start moving your left pointer slowly and returning back those extra zeros which you have flipped. So I hope the algorithm is clear to you. If you have any doubts for any question I discussed today, ask them in the comments and let's start coding this question. So I would suggest you code alongside me. That way, if you make certain syntax errors, you can check alongside and you can ask them in the comments. So let's start. So I will first initialize my left pointer with 0. I'll also initialize my max consecutive value also by 0. Now I will initialize my R and the num by using enumerate my nums array. And then, this is a trick which I'm using. So I will decrement k. As you know, when we are moving our right pointer, we need to decrement k, right? So I'll decrement k, but what do we need to decrement with and when do we need to decrement with? So we have to decrement k only when we do a 0 flip. That means only when the num value is 0, that's the time we need to decrement k. So how do you see that num value is 0? So I'll do 1 minus num. So if your num is 1, in that case, you're not decrementing k. 1 minus 1 would be 0 and you're not decrementing k. But if your num value is 0 and you're flipping it, then 1 minus 0 is 1 and you decrement k by 1 essentially. So this is a trick so that you can do it in one line rather than 2 lines. You don't have to use if then else and check if your num is 1, then decrement it, else not decrement or something like that. You don't have to do that. You can do it in one line like this. And now we'll check if our k has become less than 0. If it has become less than 0, what do you do? If it becomes less than 0, you have to give 0 back to k. So to do that, you will add 1 minus nums l, because essentially you are moving your L pointer, your left pointer. So you are giving back whatever nums L is, whether it's 1 or 0. So that's why you are adding 1 minus nums L to k in that scenario. And of course, since you are moving L, you have to increment L by 1. Now L, if your k is not less than 0, what do you do in that sense? You will check for your max cons, and it would be max of current max consecutive and right minus left plus 1. That's how you calculate the range. And finally, you can return your max consecutive. So that's your entire code. I'll run it. It's accepted. Let's submit. So you can see our solution is doing very well here. I'll quickly skim through the code again, explain you it again so that you can understand it better. So I first initialize my left pointer and my max consecutive value, which I have to return as a result, which I'm returning here. Then I initialize my right pointer along with num using enumerate. And then I use my trick which I explained. I have to decrement k only when I'm flipping a 0. That means only when my num is 0, I should decrement my k by 1. That's what I'm doing here. If my num is 1, I'm not decrementing k. Now I check if my k is less than 0. If my k is less than 0, I have to return 1 back to k. That's what I'm doing here. I'm adding nums and there basically 1 minus nums l. I'm adding it to k, whatever my nums l value is, because I am moving l. And since I'm moving l, I increment my l by 1. Else, if my k is not less than 0, in that scenario, I update my max cons. And how do I update it? I take the max of current max cons and right minus left plus 1 pointers. And finally, I return my max cons. Now, since I have explained how do you code it, what's the algorithm you're using, let's discuss about the time and space complexity here. So the time complexity here, as you can see, there is only one for loop we are using. That is, we are going from 0th index of the array to the last index of the array only once. We are looping through the array only once, and the rest of the operations we are doing are constant time operations. We are not doing anything extra. So the time complexity would be linear, O of n. And the space complexity, since we are not using any additional space apart from these pointers, which do not take any memory, so we will be using constant space complexity. If you have any doubts, ask them in the comments. If not, we'll move to the next question. Thank you.